Hey there, friends. Jeff Fritz here. And I want to talk to you about some of the other things that we can do with our Blazor projects as they grow, mature, and we want to start using some more enterprise and cloud native features because we want to start to light up other capabilities that are available to us after we deploy out to a cloud environment like Microsoft Azure. And the way that I recommend you check out these capabilities is by adding in .NET Aspire. .NET Aspire is a new collection of tools, templates, and libraries that are going to help you to add in those things that, quite frankly, you needed to put in your application. You needed more logging in your application. You needed retry logic for how you connect to the database, how you connect to other APIs, but you just haven't built it yet. You wanted all kinds of ways to collect metrics for performance inside your application, but you didn't quite write it yet, did you? And nobody wants to spend the time doing that because it's time that you could be building another feature. But when your application isn't quite behaving right, these are the things that you wish you had, and now they're the most important thing in the world because you don't have them. So .NET Aspire is going to help you with those things now in an opinionated way that's going to make your life easier, and you're not going to have to think about it at all. We're going to take a look at a sample project that's available out on GitHub. I'm going to put it in the YouTube description just below so that you can get the source code for this. This is in the Let's Learn Aspire workshop, and it's a little application that connects out to the United States National Weather Service to show you the weather at various weather stations around the United States. You can search for states, for cities, and it will bring back the current weather at that location. We're going to start off taking a look at just a simple application, and we'll add .NET Aspire into it, and we'll see how it makes our application easier to use, and then we can start adding some other cloud-ready capabilities like caching very easily right here on our local system. And because our application is built with Blazor and the ASP.NET Core, we're going to be able to take advantage of all of these features locally and get ready to deploy with .NET Aspire. Come on over, let's go over to the project and take a look. All right, here's the sample application running locally in its current environment, and I've got a simple grid here that has a list of all the different locations that I can connect to and look up weather. And I'm going to look up the weather for Manhattan. I don't even have to type everything in, and I get New York here. I'll click on that, and immediately down here, I start to get some of the weather forecast right here at the bottom. And of course, the temperatures being reported in Fahrenheit. That's what Americans prefer to get their weather temperatures in. So I can see it's cold now, but it's going to get a little bit warmer there on Wednesday. Hey, that's pretty good stuff. Now, this is running and connecting over to an API that's running using OpenAPI, and that's actually open in another browser over here, and I can see my Swagger interface that allows me to interact with those two API endpoints that then relay my requests out to the National Weather Service. But this is two applications that are running, and it's tedious, and I have to set up Visual Studio to run two different applications, and I have to connect the two so that they can find each other. And what happens when requests to the National Weather Service go bad, or when I'm upgrading this API because there's new capabilities I need to put in place, and it's not available for a little bit? These are the things that .NET Aspire is going to solve for us. Let me close down this version of the application and open the complete version that's sitting in the complete folder of the workshop. All right, this is the complete solution version, and you can see there's a couple of extra projects in here. There's my Weather Hub, that's the web front end that I had. There's my API that goes and connects to the National Weather Service, but there's now an app host and a service defaults project that are in the mix here also. These are other projects that enable .NET Aspire to be able to manage and run this application. let me change my startup project to the .NET Aspire app host. We'll start that and take a look at exactly how our application has changed, and then we'll even dig in a little bit to the source code and see how .NET Aspire makes it easier for us to configure and run this application. First thing you'll notice, .NET Aspire doesn't open my application. It opens a dashboard like you see here, where I can see very quickly, here's my weather website, here's my weather API, and we've already got a Redis cache out here, just like I might start with the Azure cache for Redis service out on Microsoft Azure. I can run and work with a test version of that locally that's running inside of a Docker container. Let me open the weather website by clicking this link. And it starts up, connects to my API, and I get the same results being displayed. This time I'll go search for Philadelphia. And there's my Philadelphia weather. And I can scroll down here and I'll start to see the weather being forecast for Philadelphia. Now, this is different this time because .NET Aspire is managing and connecting these services for us. If I back out of this filter and I instead say, let's go look for different sites in New York, I can click around here and I'll always get a response. This one's taking a little bit. There it is. It came back. There's resiliency that's built into the application now. If for some reason I'm not able to connect out and request data, .NET Aspire helps to retry and reconnect to get that data for us. Let me show you how that's built and what it does. I'll go back over to the dashboard. And if we take a look at the traces, we'll see here there's an error scenario that happened when I made a request. Look at that, it's in red. If we click into that request, you see here that there's an error that came back on this API. And we can take a look at the details for that, view the logs, and it says there was an unhandled exception. But our user interface didn't show any errors. That's because .NET Aspire has resiliency built in to show you exactly when something like this happens, it's going to retry and reconnect and eventually get there. All right. Now, I'll go back up to my console here, and I'll go to the website. And if I scroll up a little bit, you'll see here there was a warning, a resilience event occurred. And we could see that it retried and it eventually got a 200 here. It got a successful response. I can see that in my structured logs here as well, so that I don't have to go scrolling through that console. And if I take this and look for an error, I can see that error that occurred. But scrolling back here, there I can see very quickly in coloring with those warning levels that that exception occurred and it retried and it eventually got the answer. This is fantastic because I've automatically got this resiliency built in for me. I've also got caching built in. If I go back over to my traces and we take a look at one of these, you'll see it's actually trying to get it from a Redis cache locally. And because it didn't have it, it went out and got it from the API. So if I go back to one of these other ones, like Wayne, New York, where we previously requested, and we take a look at the traces, now that request, it went and got it from my Redis cache right there, and took just a millisecond to return that data. So not only do we get the retry, but the output caching means that we're making less requests to our API because we're now getting data from a cache that's being managed next to our application. Our API doesn't have to work as hard to go get data. Because let's think about it, when we use something like a weather service, the weather's not going to be updated but every 15 minutes or so. So let's cache our data for 15 minutes if it's been requested before we go get another fresh set of data. So if we get hundreds of requests for data in the same 15-minute span for the same weather, it's all going to return that pre-calculated data instead of having to go and get more from the website. Let me head back over to the code and show you how we pull all of this together. Inside my app host project here, I can declare the topology of my project and point to that Blazor application right here and say, we're going to add the Weather Hub project. I'm going to call it My Weather Hub, and it's going to reference the API. It's going to know how to go connect to my API service, and we're going to expose it as the external website for folks to connect into. I also have my Redis cache right here. I've added Redis capabilities. I've named it cache, and I can pass that reference into my API right here so that the API can cache those results that it gets from the National Weather Service. Let me show you how it uses that. Here inside the program CS, I add service defaults so I get all the logging capabilities, the service discovery capabilities, so that it can find that cache, and I also have the ability to get the resilience and logging all through adding these service defaults with .NET Aspire. But this add Redis output cache here points to that same service named cache that we had in this file in app host. And now I can use that output cache elsewhere in my application. So here in this method, map API endpoints, where I set up the connection to go and connect out to the National Weather Service and set up the API for it to interact with, I have an output cache policy here that's defined that says every 15 minutes, write a new instance into my Redis cache. Real easy to do and using existing features, but taking advantage of the ability for us to scale and use new services, new capabilities that are available on our cloud services. Finally, let's go over to the website. And the way the website works, it also has the add service defaults so that it can discover the other services that .NET Aspire is managing for us, including that API that's named here as API. And we're going to set up an HTTP client that's going to know how to connect to it. Notice I refer to just API. I don't have to specify localhost and some weird port number. It will discover and map all of that for us. So the API is going to be connected and loaded into this NWS Manager client that knows how to connect over to the API and get forecasts. By adding the API as a middle layer between us and the National Weather Service, this allows us to update that API independently of the National Weather Service, so we can add new features to our API, or when the National Weather Service changes their API, how we connect and get data from them, we can hide all of that inside the API project, and this project right here stays the same. It's a really neat sample that shows you how to connect all of these pieces to get weather data live on your desktop. Blazor with .NET Aspire is such a cool way for you to build applications and work locally and take advantage of new capabilities as they're being rolled out on services like Azure, because you have features that allow you to build and use different databases, different service bus, different cloud-enabled data storage facilities, and work with them locally. Test them out. Even use new artificial intelligence endpoints all locally on your machine. Make sure they work the way that you want them to, and then package your application and deploy it out to the cloud service so that you can be sure you've got a reliable, resilient application that your customers are going to love out on Microsoft Azure using Blazor. Thanks so much for watching. I've got a bunch more videos planned. I hope to see you soon.